Ladies and gentlemen, welcome to our first help video over our Unit 1 test. These help videos will go over every question on the test. Just find out which help videos you need to watch in order to determine which ones you need help for. Look at the ones you missed, and you'll be able to find a help video over those questions posted to Google Classroom. If the help videos do not help, in other words, you're still confused after watching the help videos, feel free to schedule office hours with me on any of the days that they're available, and I'll be happy to go over any of the questions that you are confused on. All right, beginning page 1 of our 1-13 Unit 1 test. Again, you'll correct your things directly on your test. So when you submit the test, I should be able to tell which ones you missed by marking those wrong and then putting the correct answer there. And then find the videos that go along with those. And we'll begin with questions 1 through 5. These are questions pertaining to the different branches of the subject of chemistry. All of science can be broken down into two main categories. You have your physical sciences, which would include physics and chemistry. For some degree, there'd be like geology, astronomy. The physical sciences do not study things that are necessarily alive. But chemistry is one of the physical sciences. The other main branch of science is biology, and that, of course, is the broad scope of studying anything that is living. But there are overlaps. There are portions of chemistry that study things in living organisms, as we'll soon see. The very first question on here, what do we call the study of compounds containing carbon? Well, carbon is the element that is found in all living things. There's so many. There are well over 5 million different carbon compounds. Carbon is a very versatile element. So there's a whole area of chemistry dedicated to just studying carbon compounds. And carbon is the element found in living things. Living things are alive or organic. So the study of carbon compounds is called organic chemistry, letter A, B. Number 2, what branch of chemistry studies the properties and changes of matter and the relationship to energy? That particular branch of chemistry is called physical chemistry. Again, physical chemistry is not really concerned with things that are alive. Physical chemistry is not concerned with particular types of compounds. Physical chemistry just wants to study the properties of all types of matter, changes that all types of matter undergo, and the relationship that those changes have to energy. Do those changes involve the taking in of energy, the emitting of energy? That's physical chemistry. The third type or branch of chemistry would be something that anyone interested in crime scene investigation would have to take. And this branch of chemistry identifies compounds and the composition of materials. It involves analyzing what substances are. That's analytical chemistry, letter B. There's a branch of chemistry that studies the processes and substances found in living things. The processes we would be talking about involve chemical reactions that are happening in living things. This does overlap a little bit with organic chemistry because very often the processes happening in living things involve carbon compounds, but not all processes involve carbon in living things. There could be other substances involved, but very often it is studying carbon compounds. But here they're looking at the reactions that happen in living things, and that would be biochemistry. Bio for living, chemistry, the chemistry of living things. Finally, the fifth one here, there's a very specialized branch of chemistry that involves using mathematics and computers to understand the principles behind chemical behavior and to design and predict properties of new compounds. This is cutting edge chemistry, where you're coming up with new things entirely and developing new ways of thinking about chemistry. That's letter A, theoretical chemistry. The answer we did not use above here is inorganic chemistry, letter D. Inorganic chemistry really studies all compounds It's different than organic chemistry, which focuses on carbon compounds. So inorganic is a broader scope of chemistry. It can involve carbon, but it doesn't have to, obviously. It is inorganic. It can study any compound, whether it's carbon or not. So those are questions 1 through 5. We continue down to the next multiple choice sections. And this one we've kind of already talked about. What are the two main branches of science? Well, science can study things that are alive. That's letter C. Biological or biology. Biology could be plants, it could be cells, it could be anything. It could be vertebrates, invertebrates, it could be marine biology. Anything that is alive. And then there's physical chemistry, which is not focused on things that are alive. It's a broad branch involving studying things such as astronomy. It could be the environmental or geology. If you're looking at how the environment affects living things, that would actually be a branch of biology. So physical can just be any area of science that is not really focused on whether it is alive. Letter C and E. Number 7. Alchemists. The alchemists made many, many contributions to science. However, one of these things they did not ever accomplish, and that was discovering how to turn ordinary base metals into gold or silver. It is something they wanted to do. They wanted to find that mysterious ability to have matter undergo transmutation. Transmutation is the changing of one substance into another substance. They never were able to do that. The thing they were really trying to also discover was the Philosopher's Stone. That Philosopher's Stone was that strange thing that had unusual properties of conferring immortality on those that possessed the Philosopher's Stone. And the Philosopher's Stone also was able to transmutate matter from one form into another. They couldn't do those things. That was letter C. These other things they did do. These other things were contributions that the alchemists made. Question number 8. Alchemy has the word chem in it. Alchemy. Chem was translated to be part of many different languages. The chem in alchemy was part of many different languages. But one place it was certainly identified where an area, a civilization, the Egyptian civilization, where alchemy was found, dating all the way back to 300 BC and even before that. But alchemists were documented to have existed in ancient Egypt. So chem is part of the Egyptian hieroglyphics. What does the word chem mean? It actually translated to mean black earth or the dark earth. The earth along the Nile was very rich in organic matter, which made it black. The Egyptian civilization prospered because every year the Nile overflowed the banks and dumped rich organic material along the banks so Egyptians could grow crops. The alchemists used that black earth in their studying of matter and trying to find the secret of transmutation of substances, ordinary base metals such as copper, into precious noble metals such as gold or silver. So chem is believed to come from that word meaning black earth. Some speculate it also had to do with the fact that the alchemists were discovering some very unique things and processes that could not be explained. They began to unlock the secrets of chemical reactions. They began to discover weird substances which we now call acids, which could really dissolve many metals. Things that couldn't be explained at that time were called magic. And it was black magic because it was dark and mysterious. So some think that that's where the word chem was used in alchemy. And that part of the word alchemy, chem, is where the word chemistry comes from. But chem comes from alchemy. At that time, they did not really call themselves chemists. So it's not letter E, it is letter C. Number 9, which one of the following is qualitative? What does the word qualitative mean? Qualitative means you are observing qualities. you're not making measurements. Quantitative means you're making measurements. You need to make measurements. Quantitative, you're measuring quantities. Qualitative, you're using your senses to observe qualities. Obviously, observing color, you're just using your eyes to look at a color. Letter A is qualitative. Measuring the volume would be quantitative. Determining the density of the metal, you would need to measure mass, which is quantitative. You would need to measure volume, because density is mass divided by volume. That would be quantitative. Measuring the heat energy produced in a chemical reaction. All chemical reactions either give off energy, which is exothermic, or they take in energy, which is endothermic, but that would involve measurements. You would need thermometers. You would need balances to measure the amount of matter, because heat relates to how much matter is there, as well as the temperature that is changes, the temperature changes that undergo during the chemical reaction. And you would also need to know the specific heat of matter. In other words, how hard it is for that temperature of that particular form of matter to go up or go down. That would be qualitative. Number 10. Which one of the following, or we just did number 10. How about we just did number 9, qualitative. Number 10. Which of the following is extensive property? Extensive means it matters how much is there. Extensive, if you extend how much is there, this property would change. It is unlike intensive, which is a property of matter inside this object. It doesn't matter how much is there. So really, when they're asking which is extensive, they're asking which of these matter how much is there. And we just mentioned in question number 9 that heat energy matters how much is there. Heat is extensive. To change the energy of, if you have a huge amount of water and you want to raise the temperature of that water, it would take a lot of heat energy. If you have just a little thimble full of water and you want to raise the temperature, it would take a lot less heat energy. So heat matters how much is there. The color of something is intensive. It doesn't matter how much is there. The temperature of something really doesn't matter how much is there. If I have a giant bucket of water at room temperature and I have a thimble of water at room temperature, they're the same temperature. They're room temperature. The texture of something does not matter how much is there. And the density of something also does not matter as how much is there, as we learned back in the density of Penny's lab that we did. Some of you may think, well, the density changed. The more water you would have, the higher the density would be. No. The more water you have, the more mass it would be, as well as the volume. Density is mass divided by volume. The more you have, the mass would go up, but the volume would go up as well. So density does not change on how much is there. The last one that we'll be going over in this video is question 11, which contains only physical changes. Physical changes are those changes where you would not see all the strange evidence that you see in chemical changes. Physical changes involve changes in the size, the shape, the state of matter, or the solubility, dissolving that matter in something else. Size, shape, state, or you dissolve it because it's soluble. The 4 S's. Letter A, burning propane gas would be chemical. When you burn something, you change it chemically. So that excludes letter A, because letter A has a chemical change in it. Letter B has 2 chemical changes in it. Burning a substance or reacting with an acid are chemical. The orange ones on these answers are physical. Letter C has all physical. Dissolving something in water is physical. Dry ice changing into a cloud is physical. The dry ice is frozen CO2, solid CO2. When it goes to a gas, that's physical, CO2 gas. Boiling of water. You start with liquid water. When it boils, it goes to a gas. Those are all physical changes. Letter D is all chemical. If the jewelry turns your skin green, that's a chemical reaction because the jewelry is oxidizing. A leaf changing color in the fall is a chemical change because you have a change in the chlorophyll. Newspaper turning yellow, that's a color change. That newspaper is decomposing. That's chemical. So letter D is all chemical. Thank you for watching.